Welcome back to e-Vidya. Today we will look at the remaining part of chapter number 6, Fun with Give and Take. We have already covered most of the chapter in parts 1 and 2, and the link to those videos can be found within the description of this video. So if you want to take a peek at those videos, please do so. And now we will look at the last part, which is part 3 of Fun with Give and Take. In the first part, we looked at some of the word problems, how to subtract using regrouping or borrowing concept. And we also looked at some of the keywords which help us identify what kind of operation we need to use. I'll recap those keywords, mostly surrounding the subtraction, which is what we did in this chapter. When we are given word problems and we need to identify the operation, we need to look for keywords. And for example, the problem could have a phrase that says, how many more? How much is left? What is the difference? Or simply there could be words saying remaining balls or remaining pens or whatnot, right? And some words or phrases like more than, how many more, or less than, or take away from the remaining. When we find these words or phrases, it gives us an idea that we need to subtract and to arrive at the answer. And similarly, we have a few keywords that help us identify that the operation that we need to do is addition, like altogether, both, some, and in all. We need to do addition. So this is all we covered in the first and second chapter. Like I said, these are the word problems, right? And we need to arrange them accordingly and use the right operator, whether we add a plus, whether we do an addition using the plus sign, or we do a subtraction using the minus sign, right? Here is an example. How much younger is baby tortoise? So, right, that in itself tells us that we need to subtract, right? So 150 minus 33, that is how many years younger? 117. So again, we covered all this in the first and second parts of this chapter, and you can find links to those videos in the description below. So please take a look if you want to revisit those concepts. And here is some more stuff that we covered already, and I don't want to cover them again over here. And so I will go straight to page 16, or I'm sorry, page 91. Now we are going to count to subtract. Okay, so what we have here looks like another word problem. Dalma bought 4 dozen. 4 dozen means 48. Dozen means 12, and 4 dozen is 4 12s, which comes down to 48. And gave one to each of her friends. Now 13 bananas were left. After she gave bananas to her friends, there were 13 left. How many friends got a banana? As you know, this can be found by counting forward from 13. So you count up from 13, 14, 15, 16, 17, so on and so forth, up to 48. You'll get how many got a banana, right? Or it is easier to count in jumps of 10. You can also use Kittu's home, shown on page 29, to solve these problems. If you recollect, in chapter 3, we looked at Kittu's home, which had 100 rooms in it. And there was a concept in that chapter where you jump from one room to another room, right? Say you're on room number 25. You take one step to the right, you get plus 1, go to room number 26. You take one step to the left, you go back one number, which is minus 1, we come to 24. 25 plus 1 is 26 and 25 minus 1 is 24. But if you go one step up, then we are adding 1 10. So it is 35. And you take 2 steps up, you're adding 2 tens, which is 20. So you come to 45. 25 plus 20 is 45. So each time you take a step up, you add a 10. Similarly, you take a step down, you subtract 10, so you get 15. And you take another step down, you subtract another 10. So you're subtracting 2 tens. You come down to room number 5. Anyway, that was Kitu's home, where there were 100 rooms and we were navigating from one room to another. And the math concept behind is what I just showed you. So in this problem, they were just referring to the fact that there was a Kitu's home and we navigated to get to the answer. Now, in this chapter, they're trying to do count in jumps of 10. So this is basically what they're showing down here is a number line, right? So you're starting at 13, you go all the way up to 48, right? And how do you go from 13 to 48? You take 10 steps, and which means you add a 10, you come to 23. 13 plus 10 is 23, right? 13 plus 10, right? 13 is nothing but 10 plus 3. And if we are adding 10, right? We're adding a 10 to 13. So let's add 10 and 10 1 first, which is 20. And then the remaining 3 is 23. Right? That is one way to come to 23 from 13 plus 10. The other way to do that is 13 plus 10, the old-fashioned way, right? 3 plus 0 is 3. 1 plus 1, 10 is total of 2 tens. So we come to 23. Right? So 13 plus 10 is 23. Now if you add another 10, you come down to 33. So you take one more 10, you come down to 43, right? And then from 43 to 48, you take 5 steps, so which is plus 5. So how many tens did we navigate? 1, 2, 3, which is 30. 3 tens is 30. And then at the end, there was another 5. So 35. So 48 minus 13 is 35. So you start at 13, which is how many bananas that were left, and you go all the way to 48. And for that, we had to take 35 steps. So that means Dolma had 35 friends, and she gave 1 banana to each of her friends. Right? The next one is 56 minus 37. So you start at 37 and you go all the way up to 56, I'm sorry. So the way to do that is you start with 37 and take 10 steps and you reach at 47. When you're at 47, you take another 10 steps, you reach 57, right? There were 3 tens here, you add a 10, you come to 4 tens with a 47. There were 4 tens here, you add another 10, you come to 5 tens, which is 57 here, right? But we need to come up only till 56. So we need to take 1 step back, right? And you arrive at 56, which is our final destination. So how many steps did we take? 10 plus 10 is 2 tens, which is 20. And you took 1 step back in the opposite direction. So let's subtract 1 from the 20. You took 20 steps to the right and you took 1 step to the left. So you went back 1 step. So let's subtract 1 from 20. You come to 19. So 56 minus 37 is 19. The next one is 60 minus 45. So we start at 45 and go up until 60. Now start at 45. What he did was he took 5 steps so he could reach 50. And then from 50 he took 10 steps. 50 is 5 tens, and you add another 10, you come to 6 tens. So you arrive at 60, which is where we wanted to go, right? So 60 minus 45 is, let's count the steps, 5 steps plus 10 steps, which is 15, right? And 56 minus 37, 19, and 10 plus 10 minus 1 is 19, right? You saw that over here. 10 plus 10 is 20, and minus 1 is 90. Okay? Okay. We have some more over here, and let's solve them. We have 80 minus 59. So let's start at 59. And first, let's take one jump to the right. So that is plus 1. We come to 60. Now we have to reach 80, right? So let's take 10 steps, which means we are adding a 10. 6 tens plus, right? We have 6 tens plus 1 10. You arrive at 7 tens. There are no ones over here too, right? Now we need to take, let's take one more set of 10 steps, right? So we start with 7 tens, you add another 10, one more 10, so you'll have 8 tens. So we arrived at 80, which is where we wanted to arrive. So how many steps did we take? 1, 10, and 10. So 2 tens and 1, 1. Okay. Hang on, right? 80 minus 59 is, okay, this is the one we saw, right? So 1, 10, and 10. That is 21. We took total of 21 steps. So 80 minus 51 is 20. 80 minus 59 is 21. Now the next one is 85 minus 63. Okay. 85 minus 63. Let's start at 63. And since we have to go to 85, we have 5 in the ones place. We are starting with 3 in the ones place. So in order to come at 5 in the ones place, from 3 we need to take 2 steps. If we add 2, we come to 65. Now we added 10 to 6 tens. We have 6 tens over here, we add another 10, we come to 7 tens, and write the same number of ones, which is 5 ones. Take another set of 10 steps. So we have 7 tens to start with. We added another 10, which means we will have 8 tens, and put down the same number of ones, which is 5. We come at 85, which is where we need to be. So how many steps did we take? 2 plus 10 plus 10, right? 2 plus 10 plus 10, which is 2 tens is 20, and another 2 ones is 22. So the answer is 22. 84 minus 69. Okay. 84 minus 69. What should we do here? Let's start with 69, right? And let's go up 10 steps, right? Let's add a 10. We have 6 tens, and another 10 added to it is 7 tens. And same number of ones, which is 9. We came up to 79. We take 10 more steps, which is another 10, 7 tens, and one more 10 is 8 tens, and the same number of ones, which is 9 ones, we put down 89. Okay. Now we went farther than where we should have gone. 84 is where we should have gone. We went to 89. Now we need to take few steps back. We have 9 in the ones place. We needed to be at 4 in the ones place. So count back to 4 from 9 gives me 5. Count back, right? So we are going in the opposite direction. So we need to subtract. So in all we had 10 plus 10, which those two sets of tens went in the same direction, so we add them, but the 5 went back in the other direction, so we need to subtract it. So first we add the 2 tens, you get 20, and then we have to subtract the 5 because we took those 5 steps in the opposite direction. So 20 minus 5 is 15. So the answer 84 minus 69 is 15. Okay. The next one is 60 minus 40. Okay. 60 minus 40. Oops. Minus 40. This seems like a straightforward one to me. Start with 40, add a 10. So 4 tens plus 1 10 is 5 tens. And there is no ones, so put a 0 in the ones place. So you arrive at 50. Take another set of 10 steps, right? You start with 5 tens, you added a 10, you would get 6 tens and 0 ones, right? There are no ones, 0 ones. So we came to 60. And how many steps did we take in all? 1 10 and another 10. 2 tens is 20. So the answer is 20. 60 minus, I'm sorry guys, I think I messed up. I took the wrong problem, right? They asked for 60 minus 20. I apologize. I took the wrong problem. 60 minus 20. I did 60 minus 40. Okay, anyways, let's do it again. Start from 20. Take 10 steps. Add a 10. You started with 2 tens. You added a 10, which is 1 10. So you get 3 tens, and there's no ones, right? So 0 in the ones place. The next one is take another 10 steps, start with 3 tens, added another 10, you get to 40, 4 tens, right? Take another set of 10 steps, you started with 4 tens, added another 10, you get 5 tens, no ones, 0 ones, so 50. Let's see, I think we are already here, plus 10. 5 tens plus 1 10 is 6 tens, 60. So we took 1 10, 2 tens, 3 tens and 4 tens. That gives me 40. 4 tens is 40. So 60 minus 20 is 40. Okay, the last one is 90. 90 minus 50, 50. Okay, 90 minus 50. 90 minus 50. Okay. Start at 50. Take a set of 10 steps. Add a 10 to 50. You get 60, right? 5 tens plus 1 10 is 6 tens. You take another set of 10 steps. Start with 6 tens and add another 10. You get 7 tens is 70. Take another set of 10 steps, add a 10, start from 7 tens, added a 10, you get 8 tens. Another set of 10 steps, 8 tens plus 1 10 is 9 tens. We have arrived at the desired number, 90. So how many sets of tens? 1, 2, 3, 4. So 4 tens is 40. The answer is 40. 90 minus 50 is 40. 40. Okay. Now, what do we have? Seems like some more word problems. Let's see. All the king's horses. Once there was a king who could count only up to 9. Wow. Up to what number can you count? I'm sure you could count more than what the king could. The king loved horses, but he could never count all of them. He kept them in such a way that he needed to count only up to 9 from each side. That seems like an idea. Okay, so what did he do? Okay, he put 3 horses here, another 3 horses here, okay, another 3 horses here. Right, so he's putting 3 horses in each box. So another 3 horses in this box, another 3 over here, another 3 over here. Right, so we have 9 horses here, 3 plus 3 plus 3, 9, and we have 3 plus 3 plus 3, 6 plus 3, you have another 9 over here, right? Now, if you add the remaining horses, let me pick dark green, okay? Add 3 more horses here and 3 more horses here. So you get 6, right? So we have 6 horses here. We have 9 horses here. And what was that color? Maybe orange. We have 9 horses here. 3 plus 3 plus 3. Another 3 plus 3 plus 3 and 9 and another 3 plus 3 is 6. So we have 9 plus 6 plus 9, right? Okay, they put down the numbers. 3 plus 3 plus 3 is 9. Again, 3 plus 3 plus 3 is 9, and 3 plus 3 is 6. Okay. How many horses in all did the king have? I'm sure you know the answer. 9 plus 9 is 18. 18 plus 6 is 24. Right? 9 plus 9 is 18. 18 plus 6 is 24. 8 plus 6 is 14. Put down the 8 plus 6 is 14. Put down the 4 in the ones place and the 110 in the tens place as a 1. 1 plus 1 is 2. So you get 24. Okay, which is what we wrote down. So the king had in all 24 horses. One day, a visitor with 4 horses came there. And what did he do? It was getting dark, so he wanted to stay there at night. But the horse keeper was scared. If the king saw these extra horses, he would be very angry. The visitor said, "Do not worry, the king will never know." So he arranged the horses like this. What did he do? He put 2, 5 and 2 in one row. How much would we get? 9, right? Next, 5 plus 5 in these rows, you get 10. Finally, 2 plus 5 plus 2, you get 9 again. Right? But what's going to happen over here? So, okay, let's count this all up here. How much would we get? 9 plus 10 is 19. And 19 plus 9 is 28. Let's see. 9 plus 9 is 18. So we put the ones in the ones place and carry the 110 into the tens place. 1 plus 1 is 2. You get 28. So in all, how many horses are there now? There are 28 horses. So before the visitor came, there were 24 horses with the king in the horse stable. Now there is 28. So the only thing that the visitor really did was he wanted to put the horses in a way that each row and each column would have only 9 horses. Okay. So at night, the king came to count the horses. Along each side, he counted 9 horses. Ah, that's fine, he said. Then he happily went to sleep. So what's going on here, right? Let's see. So it looks like the king was really not counting it right. And why is that? So the king was always counting each row like this, right? You get 9 over there, 3 plus 3 plus 3 is 9. And then he would count like this, 3 plus 3 plus 3 is 9. He would count like this, 3 plus 3 plus 3 is 9. And again he would count like this, 3 plus 3 plus 3 is 9. Because he could not count beyond 9. He couldn't count 10, 11, 12, 13 and so on and so forth. So he really never found out the true count of his horses. He always counted each row at a time and he always thought he had 9 horses. He did not count them all together. Now, if you follow that concept, what the king did and how he mistakenly counted, look at it over here. After the visitor arranged the horses, you would still have 9 horses. 2 plus 5 plus 2 is 9. 2 plus 5 plus 2 is 9. 2 plus 5 plus 2 is 9. And 2 plus 5 plus 2 is also 9. The king counted in this fashion. That is why he thought that he still has the same number of horses and nothing was wrong. But that's not the case, right? Really, there are 28 horses. And we just saw how we arrived at 28 horses. 9 over here, 10 over here, and 9 more over here for a total of 28. Now, what happened? The king thought everything was fine. In the morning, the clever visitor tried another trick. He took out his own 4 horses, but he also ran away with some of the king's horses. He left the king's horses standing in this way. What did he do? He put 4 plus 1 plus 4, which is 9, right? 4 plus 1 plus 4, just want to use a different color. Okay. 4 plus 1 plus 4 is 9. What was the other color? Okay, I'll use that. 1 plus 1 is 2. So how many horses are left now in the stable? 9 plus 9 is 18 and 18 plus 2 is 20. Right? There are only 20 horses now. But this visitor arranged the horses in such a way that the king would think there are still 9 horses in each row or column or whatever, the usual way how the king counted. And what was that way? He would count 4 plus 1 plus 4 in this row. He would find out there are 9 horses. And then he would count 4 plus 1 plus 4. There you go. There's still 9 horses. He would count over here 4 plus 1 plus 4. 8 plus 1 is 9. That's good. Last thing he did was 4 plus 1 plus 4, which is again 9 horses. So according to the king, he had 9 horses in each of the rows or columns that he counted, and he would have been satisfied that all his horses were in his stable. But in reality, there are only 20 horses left. So it is very, very important that we know our numbers, and it's also very, very important that we know how to count. Okay? This story is based on a Tamil folk story from the book called Numeracy Counts. Right? It's important we know our numbers. Numeracy counts. It is very, very important Just like literacy, numeracy is also important. Now that brings to the end of this chapter. Oh, okay, there might be a puzzle for us to do. Let's see. What numbers are we? If you add us both, you get 100. The difference between us is also 100. You add us both, you get 100. The difference between those two numbers is also 100. Okay. That would be 100 and 0 are the two numbers. Let's see. You add 100 and 0. That's right. The answer is 100. The difference, which means subtraction, right? You subtract 100 minus 0, that is also 100. So, when you add or subtract 0 from a number, you would end up with the same number because 0 has no intrinsic or no value to it. So, 100 plus 0 is 100, 100 minus 0 is also 100. So, the answer is 100 and 0 are those two numbers. Okay, I think that's the end of this chapter. Now, just another reminder, if you have not subscribed to my channel yet, please do so. And the links to the parts 1 and 2 are also within the description of this video. So you can revise them or revisit them according to your availability. And also, you could check out my other tutorials. Those are for Hindi textbook. You could go to my channel and you could find them. Or you could also click the I information button at the top of this video and you could find the playlist for the Hindi tutorials as well. Okay, that's it for now. Bye-bye.